All right, let's look at lecture example number 11, lithium hydroxide reacting with nitric acid. And this is a titration problem to begin with. So we're told that 0.170 molar lithium hydroxide is titrated into 15.00 milliliters of nitric acid, and that after 7.8 mils of base, so 7.80 milliliters of base, neutralization occurs. So that means equal amounts of moles of each one, and we want to find the concentration of that acid. So we are going to need to figure out how many moles of the base there were. Then from moles of base, we can figure out moles of acid. From moles of acid, we can determine the concentration. So to figure out the moles of base, it's going to be 0.170 molar. And remember that molar means moles per liter. So if I multiply that by the number of liters, 0.00780, right? This number divided by 1,000 to make it into liters, then that is going to give me, so the liters are going to cancel, and we would have had that calculator go. I should know this by heart by now. That was funny. 0.170 times 0.0078. So we get 0.001326 moles of lithium hydroxide. And then if we convert that, it's going to be 0.001326 moles of lithium hydroxide times, and it's 1 mole of nitric acid for every 1 mole of lithium hydroxide. So that means we're going to have 0.001326 moles of nitric acid. And that 0.001326 moles was housed in 15 milliliters. So if we take 0.001326 moles divided by that as liters, 0.01500, then that is going to equal 0.0884 molar. And so that is our answer, 0.0884 molar. Now we're going to want to go on to part B. In part B, it says, using our previous answer, calculate the pH when only 7.4 milliliters of base have been added. All right, for part B of number 11, it says, using the information we got from the first part, find the pH when only 7.4 milliliters of base have been added. Well, we know that 7.4 milliliters is insufficient to neutralize the acid. So for part B, we know that the nitric acid is in excess. And so if we want to find the pH after the fact, we need to find out how much nitric acid we had initially. We need to find out how much is going to be used. And then the difference between those is how much is going to remain. And then we can calculate the concentration from the remaining moles of HNO3, and then subsequently we can find the pH. So we actually know how much we had initially because we found that in the first part. It's going to be 0.0884 molar times 0.015 liters. And so that comes out to be 0.001326 moles. So that is going to be our initial 0.001326 moles of nitric acid. Now, how much is going to get used up? Well, here we know now that the lithium hydroxide, it still has the same concentration. It's 0.170 molar. But we're not using the 7.8 milliliters from part A, we're only using 7.4 milliliters. So we need to determine how many moles is that. So you're going to take 0.170, multiply that. That's still on the screen? All right. So 0.170 molar times 0.0074, and that's going to equal 0.001258 moles of lithium hydroxide. And since it's a 1-to-1 ratio, it's 1 nitric acid for every 1 lithium hydroxide, the amount of nitric acid that is neutralized by 0.001258 moles of lithium hydroxide is 0.001258 moles. So after this reaction is complete, you're going to have some nitric acid left over. How much nitric acid? It's going to be the difference between those two numbers. And that's going to come out to be 0.000068 moles. Now what does that tell me? Because what's my ultimate goal? My ultimate goal, the question asks for, what's the pH of this mixture? Well, if I'm trying to find pH, I'm not going to find it with moles of acid, and I'm not going to find it to find pH, I'm going to need to know the H+ concentration. So let's remind ourselves that nitric acid is a strong acid, and it's going to dissociate completely into H+ and NO3-. So if I have 0.00068 moles of nitric acid, that's going to yield 0.00068 moles of hydrogen ion. That hydrogen ion is in the combined volume of 15 mils and 7.4 mils. So that's going to be in 22.40 milliliters. And so now I can find my H+ concentration. H+ concentration is going to equal 0.00068 moles divided by, now that needs to be liters, so it's going to be 0.0224 liters. And so my concentration comes out to be 0.003036 molar hydrogen ion. And to find the pH, what am I going to do? I'm going to take the negative log of that hydrogen ion concentration. So the negative log of 0.003036 gives me 2.52, and that is my answer to part B. What a nightmare. And now we get to do it again for 11C, but this time the base is going to be in excess. We're ready to start lecture example 11C. And in 11C it tells us that we still have, it's 0.170 molar lithium hydroxide, but now we've added more than we added in part A to neutralize it, and so we have added it's 8.20 milliliters, and in liters that would be 0.00820 liters. Now what do we know from this? We know that the lithium hydroxide is now in excess. And what we're trying to determine, just like in part B, is the pH. So I need to figure out, like before, how much lithium hydroxide did I have initially, how much can be used or neutralized by my available nitric acid, and the difference between those will be how much remains after the reaction is complete. So the used, all right, we can find, and we had it in the last two problems, because it's still 15 milliliters of 0.0884 molar nitric acid. So the nitric acid is going to neutralize its equal number of moles of lithium hydroxide because it's a 1-to-1 ratio. So that is 0.0884 molar times 0.0150, and oh, is that really 0.001326? Yes it is. So that is the amount that can be used up. 0.001326 moles of lithium hydroxide will be neutralized by 0.001326 moles of nitric acid. How much lithium hydroxide do I have this time around? Well, we'll do the same thing. We'll take its concentration, 0.170 molar, and we'll multiply it by the volume, 0.00820 liters. And initially we have, what is that? I think it's 1394. 0.170 times 0.0082. Yeah, it's 0.001394 moles. So that is my 0.001394 moles of lithium hydroxide, and when I subtract that, the number that I get is how much remains after the reaction is complete. And it's going to be 0.000068 moles of lithium hydroxide. Now let's talk about what we need to do from there, because we're not even close to being done. If I want to find the pH, but I have excess base, I am going to first need to find the pOH. And I'm going to find the pOH from the hydroxide ion concentration. And I'm going to find the hydroxide ion concentration by figuring out how many moles of hydroxide I have in what volume this will be present in. All right, I'm going to erase that because we are officially done with that information. All right, so little reminder, lithium hydroxide is a strong base. So it's going to dissociate completely into lithium ion and hydroxide ion. So if 0.00068 moles of lithium hydroxide are in water, they are going to dissociate into 0.00068 moles of lithium ion, which we don't really care about, but it's also going to make 0.00068 moles of hydroxide ion, and that is where our interest lies. So I need to know the concentration of hydroxide ion. Well, it's going to equal moles, 0.00068, divided by, and that's going to be the number of liters. And what did we combine? We combined 8.2 mils with 15 mils, and so that's going to be, what, 23.2, but you need it in liters, so it's 0.0232 liters of solution. So our hydroxide ion concentration comes out to be 0.002931 molar. If I take the negative log of that, of the hydroxide ion concentration, that equals POH, and I know that pH plus POH always add up to 14. So what's the negative log? The negative log of our hydroxide ion concentration gives us 2.53. 2.53. And so that means 2.53 plus something equals 14, and that something is going to come out to be 11.47. And I think we want this as 3 sig figs, so our answer here is going to be 11.5 for a pH. All right, so that is number 11.